So number 2, I came up with those 2 points in blue over there marked on the graph. So I came up with 2 of them, and I put at the points marked on the graph, the slope of f of x equals the average slope of f of x. Another way to say it is those 2 blue points are where the tangent lines are parallel to the secant line on the interval. Another way to say it, you could say that's where the curve has the same slope as the secant line. That's where the curve has the same slope as the overall average slope. Brendan. Sure, yep, I like that. Yep, that works. There's a number of ways to word that. Don't feel like there's only the one way. There's other ways to do it. Any questions on that one? Let me give you just one further visual real quick. This orange line would represent the average slope, aka the secant line slope. And then these 2 red lines, these would be the tangent lines. And you can see that even with my mediocre line drawing skills, they look fairly parallel, roughly. That's what we're looking for. Is there any other follow-ups on 2? Talk about number 1? Yeah. All righty, here is number 1.
Explain it and I figured it out.
I almost forgot about coming out. I first looked at it, I'm like,
Hey guys, had a couple requests to, you guys can listen up please. Had a couple requests to go through this in a little more detail. So what I've done here is I've split it up into 2 separate integrals. And when you split it up like this, doesn't the second integral become a little more obvious? What's the antiderivative of secant squared? It's tangent. So I can right away just put plus tangent of x plus c, but I still need to handle that first term. So here is what I'm thinking. So Kenna, this is kind of what we were talking about earlier. So what I'm going to do is I'm going to put a red box around something. Do you all see how that is a pretty clear composite? In other words, the input for sine isn't just x, it's something a lot more complicated, right? So this is really key that you recognize this. We don't want to just brush right on past that and not realize the importance of it. The fact that this is composite is going to push us either towards the whole Timmy thing, or if you don't like the Timmy thing, towards substitution. The goal of substitution and the goal of the Timmy thing is exactly the same. It's just a slightly different way of thinking about it. And to be honest with you, the more you do it, the more you'll see that they're really sort of the same. It's just the substitution steps it out in a bunch of little steps. And with the Timmy thing, you're thinking about it a little bit more mentally instead of writing it down. That make sense? We'll try it out here. So if that's composite, I'm going to put a green box around the inside function. You guys okay with the inside being e to the 9x? Okay, so here's how I do the Timmy thing. I'm going to ask myself, what's the derivative of the green box? What's the derivative of the inside function? And you would say? I got to get that chain rule factor in there, right? So I'm going to erase this. Hey, guys, check this out. So the derivative, this is what I'm doing in my head. The derivative of e to the 9x is 9e to the 9x, right? And what I need to do now is I need to compare that, comparing that right there to that right there. Are they exactly the same?
no.
They're not exactly the same, but aren't they really close? Timmy messed up.
Timmy.
He always does, or seems like he always does. He's off by what factor?
9.
So what I need to do is I need to multiply the inside by 9. Now, by doing so, I have a perfect chain rule pattern. The derivative of the inside is truly the other factor. But as you know, you can't just do that. You can't just change things because you want to. It's got to be logical. It's got to be balanced out. How do I balance out the fact that I just multiplied by 9? Divide by 9, which of course means I really multiplied by 1, which is okay, right? It doesn't change anything. So I multiply the inside by 9, I divide the outside by 9, and now I'm set up. Does that make sense? Okay. So then to finish it, I got to remember that the 4/9 doesn't go anywhere. And all I really need to do is find the antiderivative of the big box. So that would be negative cosine of e to the 9x. And it's usually at this point, there's always at least one or two people that look at what I'm highlighting in yellow and say, well, hey, I get that the antiderivative of sine is negative cosine, but where did the yellow stuff go, right? Because it seems like the yellow stuff just disappeared. Do you know where it went? That's right. Even you got the hand motion. It went back inside the box, right? Think about where it came from. It came from a chain rule. It just goes back into the input where it came from. If you doubted, which you're okay if you do, if you doubted, you could take this in the blue box and you could just do a derivative of it, and you'd find that it is actually exactly the same as what you started with for your integrand. Okay, so I feel like we've made progress. I'm wondering if there's maybe some other lingering questions. Brendan.
Is that supposed to be negative 4/9, or is it not supposed to be?
So I put 4/9 times negative cosine.
Oh, I didn't even see that. Never mind.
You could change the order around a little bit if you wanted to, and that'd be fine. That's good.
Just completely overlooked.
Isn't this a case where whether I put parentheses or not would be a huge deal?
Yes.
It'd make a big
I
difference.
don't have enough parentheses.
Sure I do. I have exactly the right number of parentheses.
Wait.
The 4/9 only applies to the first term.
You have to close the cosine.
Oh, I don't have the right number of parentheses.
There you go.
I would say that wasn't wrong, but it was ambiguous, right? It's like, well, where do you close the parentheses? Now we know. Yeah, that's right. I'm glad I had some parentheses at least, but boy, I lost one of them. Okay. Do you guys have any other questions? Hey, strap it on. Let's go. You guys ready? We're going to do some hardcore antiderivatives. Hey guys, listen, please go back in time. Back one page to number 3. It's right there. Hey, guys, we need to make sure these transitions are quick. Okay, when we go from one question to another, we'll take hopefully as much time as we need to be good at these. But if we have to take 2 minutes for you to get resettled down, you will absolutely lose out because we will not have time to get to all that we need to. Make your transitions fast. I'm gonna start this one. I'm gonna do some of the cleanup work here, but you try it, okay? You go. See what you can do. And if you want to just follow along, I'm gonna quietly do this. These first couple steps are the ones that I always do. And you should be in the habit, especially with these more complicated antiderivatives, you should be in the habit of doing these exact same things. Two opportunities here really to practice substitution or tuning. Hey, while you're doing that, I want to make mention of, you guys remember those little half sheets I handed out yesterday with the new retry stuff? And there was also the sign up for Edpuzzle thing. You're going to want to do that because for tomorrow's class, this will be probably, I think, either only the 1 or 2 times for the whole year. Tomorrow we're going to have what's called an intro video. So this is all in your Schoology. And it's through Edpuzzle. So before you come to class tomorrow, you need to have completed this Edpuzzle activity, which is, it's already in your Edpuzzle class, and it's already linked in your Schoology. I haven't checked the whole list, but I know right now there's like 24 people that have signed up, and I should have like 43. So I'm guessing that at least some of you have not signed up for that. You are going to want to. There's about a 10-minute intro video. I'll just let the cat out of the bag. It's about rectangular area, and it's about trapezoid area. Honestly, like that's all it is. How does that relate to what we're doing? You'll find out. You're going to want to have that completed prior to you coming to class tomorrow. If you watch the intro video after class, I'm sure you understand how that's very silly. So it's meant to give you some momentum heading into class. So just look in your upcoming, like your coming ups. There it is. You click on that.
Oh, that's how you can see.
So you can access it through there, or you can sign up for it. When you set up puzzle using that little code,
It's a great art class.
and you'll see it, and it'll say, intro video for area approximation.
Okay.
Because if it's in the top,
Yep, so it's just that little code.
Oh, because that is supposed to be 28.
Oh, 28 is a number you should be talking about.
Why?
You should be talking about 28.
You have to multiply the top and then you have to undo it.
Arctan has a U prime times A. And so if you
Oh,
take
it's all coming back. Oh, I'm so glad.
in the bottom, or U squared, you could find that U is 7x. And then that A would be 4. So it's A squared plus U squared.
Because it's
And
on the
so
top.
on the bottom, that's what it is.
So
You want the top, he said it well, you want the top to be U prime times A.
U prime times A. And so when you find that it's 7 times 4, which is 28. And then since you have it on that top, you're multiplying it in order to balance that out.
Okay, let's check this one out. You really have to separate these into 2 separate integrals like I already did. The first one is obviously not a fraction. Timmy messed up. Does anybody want to venture a guess as to by what factor he messed up? 3. That's right. So the other factor should be a 3, but it's only a 1. So if I multiply the inside by 3 and then balance that out by dividing by 3 on the outside, I'm set up for success. And I think my final answer for the first part would be 8/3 e to the 3x plus 1 plus, now we got to do the other part. How you guys feeling about that first term? Good, okay? Okay. So the second one, this is a little bit more like what we did yesterday. This is obviously a fraction. And so with fractions, we want to run through our possibilities. Is it natural log? Is it flip up? Is it arctan? Is it arc sine? And so we want to run through these possibilities. I like to go in this order. So let's start off. Number 1, does this look like natural log? Why not?
Because you have to have an X on top.
You would have to have an x on the top. That's right, because weren't we looking for the derivative of the denominator being equivalent to the numerator? You look at that derivative denominator, it's 98x. The 98's really not a big deal, but the x is. Timmy messed this up so bad that it's not even ln, right? It's the wrong form entirely. So we eliminate that. Flip up, I feel like this is the one that you have to either in your head or on paper, just try it and see what happens. So this is what you could write down if you were going to try it. 16 plus 49x squared to the negative 1. And as soon as I write that, I realize there's a problem. What's the big problem? The negative 1 is a huge problem. Why?
Because as soon as you add 1 to it, it becomes 0. So it just end up having to be, like if it was like, I don't know how to explain it.
It would be to the 0, which,
Like 1.
so that seems weird, but that's not necessarily a really egregious problem, is it? What's the big issue? After you add 1 to get a 0 exponent, then you would have to not multiply. When you do the power rule for antiderivatives, you add 1, and then you divide by the new exponent, which would be 0. It'd be division by 0.
D&E.
You can't do that, right? No, it doesn't mean that it's D&E. It just means we have the wrong form.
Can you explain this one more time?
Sure. So if I tried this, power rule, even if I ignored the fact that Timmy is messed up beyond repair, if I tried this, if I said 16 plus 49x squared to the negative 1 plus 1 divided by negative 1 plus 1, what's negative 1 plus 1? I just divided by 0. That's a problem. So that means not necessarily D&E. It just means it's the wrong form. We don't give up. We don't cry too hard. We just try something else. Okay. So it's not ln. It's not flip up. Of the only two possibilities, which is it not? Why not?
Because there's no square root.
The square root and the whole minus plus thing, right? Yeah. So it's got to be arctangent. If it's going to be arctangent, we need to have the right fit. So we need our u prime, and our a. What would the u have to be if this really is going to be arctan?
7x.
7x. So therefore, of course, u prime would be 7. How about the a? 4. So please recall from back in your derivative work and the kind of the basic antiderivative rules, for this really to be arctan, doesn't the numerator have to be u prime times a?
Is it u prime plus a?
Times. So what's u prime times a? It's 28, but the numerator is just a 1. So for what seems like the millionth time, Timmy has messed up again. So I just go times 28 divided by 28. And now I've got a perfect chain rule pattern for arctan. My final answer would be 3/28 arctangent of 7x over 4. And after all that, please don't forget the plus c. So the blue box would be your final answer.
Would it have been wrong to actually do it?
You will.
A also technically be negative 4. Like, how do we deal with that? Because of the square root.
Oh, you're saying like plus or minus?
Yeah.
Yeah, you're misusing that whole thing. You can only do that with an equation. There's no equal sign in there at all.
Well, we don't know what A is, and A squared.
Let's not spend any more time than this. Like, this is more of like an algebra concept of like, you didn't square root both sides is the problem. When you do a square, like when I write, I'll take 10 seconds to do this. When you write this, you're telling me that you want the positive square root of 16. If you wanted the negative square root of 16, you would have written that. And we don't want that. Seriously. Yeah, let's not spend any more time on that. Go ahead.
I'm just confused about the 28.
So it comes down to form. So in order for it to be arctan, the numerator has to be u prime times a over a squared plus u squared. This is equal to arctan of u over a plus c. So for this to be arctan, the u has to be 7x, which forces the u prime to be 7. And 16 is just 4 squared. So u prime times a is 7 times 4, which is 28. So the numerator has to be 28. And it's not. So for this truly to be arctan, I need to make the numerator 28. So I multiply the numerator by 28. I can't do that unless I also divide by 28. And that's what this is all about.
Okay, so then how do you get from the 28 over 16 plus 49x squared to 7x over 4?
Well, so it's arctan of u over a. There's my u, there's my a.
And that's always how it's going to be.
That's always that pattern.
Arc sign.
Yep.
U over a, but then you have to look out for arctan because it's the u prime times.
I would say like,
Yep.
I would say it was like
Okay.
66.
Hey guys, I'm going to flip the order around a little bit. There's something that we need to get to. So let's see here. Hey, guys, hey, the transitions have to be fast, okay? They have to be fast. I really want to come back to 4. But, darn it. Okay, so here's what we're going to do. We're a touch behind. So we're going to do 2 together. This is on today, so we're going to go forward in time to today. I want to do 2 together, and then we're going to go ahead and do 4. We've got to get to 4. Ah, shoot. Let me think here. Yeah, we'll do it in this order. Okay, let's work on this one together. Okay, so number 2. First thing we're always going to do is we're going to take multiple terms and we're going to split them up. These are very different. We're going to handle the first one first. So, clearly a fraction. And what's the first thing you should ask yourself about when you're working with a fraction? Yep. And we end up with natural log. And is this going to lead us to natural log? So when you're considering that question, what you're really asking is the derivative of the denominator equivalent to the numerator? And the answer is, well, it's not, but we can get there, can't we? Timmy messed up by what?
8.
Factor of 8. So, isn't the derivative of the denominator 8x minus 8?
Yes.
So if I just multiplied the top by 8 and the outside by 1/8, I've got a perfect chain rule pattern for natural log. Does that make sense? Brendan, what part of it doesn't make sense?
I feel like you just like went way past it. I have no idea what just happened.
Hey, so listen. I'm going to do my best. I have to do this efficiently because we can't stop here. Here's the question. No, here's the question. If you're considering ln, you ask yourself, is the derivative of the denominator equivalent to the numerator? So doesn't that require us to figure out the derivative of the denominator?
Yeah.
So you can do that in your head, right? It's fairly easy power rules.
Oh, I get it.
8x minus 8. Well, the numerator is just a factor of 8 away from that. So guys, this first one would be 1/8 natural log of the absolute value of the denominator. Plus. Clearly the other one's fraction. What jumps out to you about the fraction on the second term? Somebody said synthetic. Yes. It's division. Why would you pick division? It's a degree thing. That's right. So let's do this off to the side. You guys are on it. This is great. So synthetic division would be 1, 3, -5. What goes in the little box?
-8.
That's right. So I'll let you guys do this. I'll do this quietly up here. So there's what you do with your remainder. You just put it over your divisor.
So is that just getting rid of it?
So that's just the simplifying it. Now we're going to do our antiderivative.
Okay.
I've just got it into a form I can work with now.
So this is just math.
Can you do an LN now? Or no?
So there will be a natural log involved, yep. Okay, so when you actually attempt this, the first term, isn't that just a pretty basic power rule? So it'd be plus 1/2 x squared. What's the antiderivative of -5?
-5.
And then you get to that last term, and we can make this as complicated as we want. The 35 is just a constant multiple, right?
Yep.
So what is this going to end up being? What kind of thing? Natural log, that's right. So we'd finish with plus 35 natural log absolute value of x plus 8. And then please, after all that, don't forget the plus c. So that tie comes from this. This is x to the first. Add 1, divide by the new exponent. Yep. Okay, how we doing? Shake.
I'm confused with the first part with the 8 on the top. Where does that end up?
Where did that end up? All this whole numerator,
It goes in.
it just goes back inside. It just goes back down into the denominator as we reverse the chain rule. It's the Timmy thing, right? Like all the derivative of the inside stuff, when we repackage the packages, it just goes back inside.
And then for the 35 and the x plus 8,
Yeah.
how can we, like if I wasn't in class just doing this at home, how do I know that that's ln since the derivative is
Hang on.
the same as the top?
It is. So I get the 35 out of there. And now you look at the denominator. What's the derivative of x plus 8? It's ln. Yeah. Hey guys, you bet. Guys, let's move on to number 4. Oh, Bex, did you have a question? Were you stretching? Okay, good. I was hoping I didn't miss you. Hey, we're going to finish, guys. We're going to finish with the proverbial bang here. You're not going to want to mentally check out. So let's work through this one together. And let's do some of the obvious stuff first. Wouldn't this be kind of the obvious stuff? The split up and the getting the constant multiples out of there. The obvious stuff, just clean it up, split them up, get the constant multiples out, and we're ready to look this over. So here we go. You can tell, obviously, that they're both fractions. I am going to focus on the first one first. Let's go through. Just focusing on the first one only. Is it natural log?
No.
And it's not even close, is it, right? I mean, the derivative of the denominator is 2x minus 8. 2 terms. The numerator is just, I mean, it's not even close, is it? So it's not natural log. Can anybody explain why it's not flip up? The -1 thing, that's right. It would be blah, blah, blah to the -1. We're going to end up with that same problem. So maybe you would be able to recognize that mentally
What case would you be able to flip up? Because would that always
if the overall exponent of the denominator is not 1. If it's like, if it's like a radical or like to the 7th or something, then that's a possibility. Okay, so guys, hey, listen, don't lose focus. I hope you don't. So we come down to the end here. It's either arctan or arcsine. On the first one, which is it definitely not?
Arcsine,
Why?
because it doesn't have a square root.
There's no square root. Okay. It's got to have a square root for it to be arcsine, and that's not there. So it's got to be arctan, but if you're honest about this, this still doesn't even look right, does it? Because I'm going to erase this, but isn't arctan supposed to be u prime times a over a squared plus u squared? We got like this extra term. So Grant suggests factoring. What? Oh, yeah, what? That's it. So Cole has stumbled into it apparently. Well, oh, he was looking ahead. Yes. So, guys, let me explain when this happens. Listen. If you eliminate ln, you eliminate flip up, and you think it's got to be arctan, but it looks like it's just a messed up form, then very likely it's going to be a complete the square situation. So here's how we do this. I'm going to complete the square on the denominator. Here's how this works. This is actually the easiest version of completing the square. You group the first two in parentheses, and you leave a little bit of space. And then if you remember to complete the square, don't you find the b, cut it in half, and then square the result. So what is the b? The b is -8, cut it in half, and then square the result. So what you do then is you add 16 to the inside, But you all are aware, you can't just like add 16 and call it good. You have to balance that out by doing what?
Adding 16. Oh.
Subtracting 16. There we go. Okay, so
Always like one off.
this is now factorable. So it would be x minus 4 squared plus 25 minus 16 is 9. This is actually going to look much nicer on the whole arctan thing. Check it out. 3 antiderivative 1 over a squared plus u squared. Do you see it? So what's your a going to be? And what's your u prime? 1. That's correct. Your u prime, because the u is x minus 4, isn't it?
Yeah.
A squared plus u squared. So the u is x minus 4, so the u prime has to be 1.
So then it's 4.
And the a has to be 3. So the numerator would have to be
3. So
3. So we'd go times 3 divided by 3.
this is like the smartest thing in the world.
So it ends up being arctan, 1 arctangent of u, which is x minus 4, over a, which is 3.
That was so smart.
Where did you get the 3 in the top?
So the top has to be u prime a,
Yes.
and u prime a is 3.
Okay.
So the top should be 3, but it's a 1. Yeah.
U prime is 1. Okay.
Right. Okay, so guys, hey, listen. Transitions have to be quick. The other one, let's go through these quickly. Can you tell that the other one's not natural log? What's the one symbol? Square root. It's also not flip up because the inside is way too messy for flip up to work. So you're left with this arctan, arcsine decision. What if it's going to be one of those two? Which one does it have to be? Because of the square root, right?
Yeah.
But then you look at the inside, and isn't the inside supposed to be a squared minus u squared? We got to complete the square. That's right. Anna,
You're so smart, bro.
you can tell just from sitting there paying attention, you're on it. Love it. Okay, so guys, this is a slightly more complicated complete the square. So in our final couple of moments, don't lose focus. Here's how this works. You group the first two, just like before. First two are grouped. Left a little space, but this one's weird because to complete the square, the lead coefficient must be positive 1. And right now it's negative 1. So I've got to factor it out. So it would look like this for real. I've now factored out that negative 1, and I've got the right form. So what we do next, of course, is just cut the b in half and then square the result. So if I do that, what do I get?
1.
So I'm going to go plus 1. This is what's so tricky here. I didn't really plus 1 though, did I? Because of this, didn't I really subtract 1? So I have to balance it out by going plus 1. This one's tricky. So this one goes negative x minus 1 squared plus 81. So then this becomes 5 antiderivative 1 over square root 81 minus x minus 1 squared. And of course, this now looks a whole lot more like arcsine. How badly did Timmy mess this one up? He didn't mess it up at all, did he?
There's a 1 on the top, right?
So it's supposed to be u prime on the top, right?
Yeah.
And if u is x minus 1, wouldn't u prime just be 1? For the first time in like forever, he didn't mess it up.
Does U always have the X in it and A always doesn't?
Yep. So this would be this, and it would be x minus 1 over 9. And again, after all that, please, for goodness sake, don't forget the plus. Okay. That's it. Sorry I kept you a little bit late. Have a great rest of your day. Please don't forget to do the intro video for tomorrow. It's an intro, not an outro. Okay? Intro video. Please do it before you come to class.
You said you wanted